So now if we hit play, and we go LAN host, we are both the server and a client. As a result of spawning the player prefab, the start function on that player prefab runs. Now, on this one, we're both the server and the client, so the is server is true, and it goes and does that. Now, what we're going to do is we're going to take the next step over here. I'm going to go and do a build and run, and I'm going to make a folder for builds, and we'll call this, I don't know, Panzer Win 32. Well, it might be 64. I don't know. Panzer Windows. Boom. So we're going to compile this, and we're going to see if we can connect up. And when we use, I'll set up the Unity multiplayer matchmaking service for this one, so we will actually be able to connect and play with each other at some point. But right now, I'm just going to play with myself. So be windowed, yeah, at a smaller size. Come on in here. And so, yeah, obviously we'll do something else with our little play area here. I guess what I'll do is I'll start this one as a host. So I'm both a server and a client. So there's my player prefab over here and my tank over here. And then I'm going to swap over, and as a client, I'm going to connect to the same server. First of all, you can see the sync var. The time is synchronized. Now, this one, it's twitching a lot faster because on this screen, this is the one that's updating every frame. And on this one, this is the one that's only updating on every network update, so every 10 milliseconds. So it's a little less twitchy, but it's still pretty darn fast. And at this point, if we take a look, you can see there are 2 player prefabs and 2 tanks available. Okay. We're getting there. Now, it's worth noting these tanks are not actually, from a network point of view, in the Unity high-level networking, these tanks are not owned by the player. They don't have local player authority. So if a player were trying to make changes to this tank, it can't actually send messages to the server's version of this tank as is. What do I mean by that? Because I'm not doing a very good job of explaining it, but it's there. Again, that's right. And the other thing too is the second tank doesn't go away on the player disconnection, but that's something we can work out. So the question is, let's say you want to make a change. You want to send a network command on the network with regards to a particular object. You want to say this tank wants to move 3 pixels to the right. That specific command where I say, it's a script running on the tank itself, right? There's a script on the tank, and the script on the tank says, hey, everyone on the network, I'm moving 3 pixels to the left. The only person that's allowed to send that network message on behalf of that object from a script that exists on that object is the person with the local authority, or the authority of that object. Now, by default, the server always has authority over the object. That's fine. But you can set it so that an object belongs to a particular player. Now, by default, a player will have authority over their player prefab object over here. And, I mean, there's a bunch of ways to check it. First of all, we can check to see, are we the local player for this object? Yes or no. But the other thing we can say is, what is it? Authority, has authority over here. Now, has authority should be true for our local player object, and it'll also be true if an object was spawned with authority for this player. By default, something that was .spawned is only owned by the server, period. Not owned by anyone else. But you can spawn with client authority. And if you do that, then you do have to specify the connection of the player, which I think player controller ID is a valid option here. Because you can either give it the game object of a player, which actually would be this. I could just send this. That would work. Or I could send the network connection object, or the asset ID. Okay. So, sorry, connection to client then. Past that. So this is the connection to the client that owns this object here, this player object. So then what we would do is we would tell the network, all right, we're spawning this object. Also, this particular client has authority over this item. Now, as far as I know, all the clients in the game will ignore that particular message. Like, they'll see it and be like, well, that's not me, so I can ignore it. The one who actually matches this one will say, oh, I get to control this directly? Cool, I'll make a note of that. And the server also makes a note of that. So that way, whoever owns this object, if there's a script on that object that checks for, say, do I have authority? Yes, I do. Okay, I'll make changes. I mean, you can try to make changes anyway, but if you don't actually have the authority and you try to send it to the server is just going to ignore you. But if you do have authority over that object and you make a change to that object by sending, say, a command, then the server will actually listen to it. So we can do that. And the question is, are we going to have authority over the tank object? The thing is, we don't need it in any way whatsoever. We do need some way to tell the server for our tank, hey, we really want to move to the right. But there's a bunch of different ways to do that. I can go and save, like, I can save game object, my tank, and then over in my update, remember, this is my player over here, but in my update, there's no reason I can't do something like, you know, if some input, yada, 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 then tell the server, so command, moving my tank, you know, some coordinates. So I'm just telling the server, hey, I would like to do that. And then over here, you could have your command. Float X, Y. I should have just done a vector. I'm not necessarily using this. We'll have to have a discussion as to how we want to do it. Commands only run on the server. And so now what we do is say something like, oh, okay, so we'll move our tank dot transform dot translate. Oh, it's capital T. Translate X, Y, and Z. Boom. So you can do something like that, right? There's no reason you can't move the tank this way. Even though you as a client don't have authority over your own tank, you have authority over your own player object, and the player object could send a message to the server and ask the server, hey, server, could you please move the tank over here? And the other funky thing is there's nothing stopping you from moving or making changes to a game object on your side. You can do that to any game object in the game. It's just a Unity program, right? I can take any game object in the game and change its position. There's nothing stopping me from doing that. The difference is, any changes I make like that don't get broadcast to the network. But there's no reason I couldn't, over here, send move command to the server. And also, to eliminate any appearance of latency, go ahead and move my local version of my tank. Right? There's no reason I can't do this. And then you put in some sort of note. If this move wasn't legal, when I get the updated position of my tank from the server, I might rubber band to another location. This is a perfectly fine way to operate. Why not use a network transform? Or why not use... So, with a network transform, whether or not we use a network transform or we write another script, that idea is, instead of running the code as part of the player, right? The player just sends a signal to the server and asks for stuff to happen. Instead, we have a script that exists on the tank object itself. And on the tank object, we could send commands to the server on behalf of the tank if and only if we have local authority. So that's the difference. You don't actually have to spawn things with client authority, because this makes no difference here. What we've implemented here, the client authority makes no difference whatsoever. We could just spawn here because the server knows what our tank is supposed to be, because this my tank, assuming when we actually spawn our tank over here, right? My tank, like that. There you go. So the server knows which one is our tank. And so it'll make the move. And this works perfectly fine. If you were instead to have the movement script exist on the tank itself, it would need 100% to be spawned with network authority, and that the tank itself is saying, hey, I've got a message here from related to myself from the authorized client saying I would like to move. And what the network transform script does is, instead of sending a message explicitly yourself, you just change your position, and the network position script is responsible for updating. And every frame or whatever, it checks to see, hey, has my position changed? Oh, it did? I better tell the server that this has happened. And every client listens to it automatically. There's no reason you have to write a network script. Again, I keep trying to sort of emphasize that. There's no reason you have to use a network transform script, and there's no reason that my tank actually needs its own movement script on it. But I think it makes a lot of sense to have the tank in this particular context be responsible for listening to keyboard inputs and things like that, so that we can keep our code nicely segregated. The player probably shouldn't, the player script shouldn't have to deal with tank movement logic. I think that's swell, so we're going to go ahead and remove this over here and that over here. The player can still be responsible for spawning its tank, that's fine, and the player will still probably want to know, hey, which tank is my tank, just in case. But instead, we're going to go back to Unity over here, and our tank over here, chugga chugga chugga. So our tank object over here, we're going to do two things to it. First of all, I will add a new script. I'm going to add a script called tank on it. Boom, done. So some sort of tank logic is going to occur on there. We might skip network transform because I think it'll be quite, it'll be valuable to sort of discuss some of that. And we have to mark a local player authority. So this flags that this object here can technically be owned by a player. A local player is going to be potentially allowed to use this. Even if with this on, by default this does nothing, because the server still has to spawn the object. The server is the only thing that's allowed to spawn it. And unless the server specifies who the local player for this object is by doing spawn with authority, this checkbox does absolutely nothing. But now that we do have that, again, when the player spawns here, we will want to make sure to go and do the spawn with client authority, and again we will specify that, hey, this is the client with it. So one of our clients will know, oh, I'm the local authority for this object. Cool. As far as I know, and I did some testing, I think you need to do both. You need to do this, and you have to have that checkbox on. If you don't have both, it's not going to work. So now that we have that, the server, this is still run on the server, is responsible for spawning it, but now I have too many windows open. Now, if we open up our tank script, I guess I could have just expanded this over here. There we go. We still want to do .networking, and we still want to do derived from a network behavior. Oh, I was like, why is there an underlined? Because semicolons. You've watched 300 hours of Quill programming in the last 2 months? Wow. Make a ranking system like the host is general and take orders from him. You could totally do stuff like that. So this tank, this script, remember, this script will run on all clients and on the server. Remember that. This script is running, anyone who has a copy of this tank object, it'll run everywhere. And possibly the server and one of the clients will be one and the same. Depends. You can be a standalone server, in which case you are not a client anyway. But the most common thing is to host a game where you're both acting as a server and one of the clients. And in additionally, one of the clients may be the local authority. interestingly enough, if we have AI-controlled tanks that the server is spawning, the server might not give anyone, wouldn't give anyone local authority over the AI-controlled tank. It would only be itself that would be allowed to control it. But that's covered by has authority. So the thing that comes down is, so first, we'll break the update into two over here, actually. Here's what I'm going to do. I'm going to have void authority update. Sure. Void other update. Or generic update, or something like that. What we're going to do here in the update is we're going to break it down. If has authority, this is my object. I can do whatever I want with it, and the network will listen. Authority update. And then what we're going to do is over here, we're going to call other update. Do the, I guess, you know what? We could just do the rest of the update in the update function. I like that. So normally I check to see if something like has authority is false and then bail early. But now I want to do it in the other way around, because do generic updates for all clients server, like, you know, animating movements and such. That sort of thing. One thing I'm curious about, does have authority actually fire if you're just the server? I'm hoping the answer is no. I'm hoping that has authority is implicit to has local authority. But we have to check here, because we don't want authority update to run for both the server and the authoritative client. So what I'm going to do is I'm going to make a build. Just got to double check this, because otherwise things could be wonky, because we might have to do has authority and not equal server, or I don't know, something. So this is going to be the server only. So it's not even a client. And then over here, we're going to connect to the server. And confirm, okay, has authority did not run on the server. That's good. Whereas if I stop this and I'm both, say, the client authority update does run every frame. Good. Okay, excellent. Just got to double check. So, this is my object. I can do whatever with it, and the network will listen. We could also do a thing like if is server, you know, maybe we need to do some server specific checking maintenance. Because here's the thing. Stuff that's in the has authority will run on the client side. And presumably then gets repeated over the network. But there's some things, like let's say you get set on fire, okay? And you're supposed to take damage every second. We could have that happen here on the, you know, in the client has authority side. And then we would have to trust that the client that owns the tank isn't running on a hacked client that ignores damage or something like that. So instead, we might want to do in the is server thing, this is where we want to apply the fire damage and tell everyone that, hey, I took fire damage. Now, the owning client can still ignore that. And so, like, if I'm running my hacked client and I'm playing in this game, it shows my health as 100% all the time. I'm like, ha ha ha, I am elite hacksaw. But the thing is, the server and all the other clients know that you're down at, like, 10%, 5%, 0%. Oh, you're dead. We're removing your object from the game. So from my point of view, it looks like I still exist and I have 100% health. But the fact of the matter is, no one else even knows I'm alive, and they're just going to ignore everything that I do from now on. So it doesn't matter that I'm cheating. I'm just cheating my point of view. Now, the thing where some of this stuff matters is if you're cheating with like visibility hacks or something like that and being able to see places maybe you're not supposed to see. That's a whole area something. But so that's something to consider. Anything like taking damage or whatever, you might want to do stuff there. Example. Have the tank take ongoing damage. Now, if you're hosting the server and you're running a hack thing over there, that's a whole other thing. But, I mean, that'll be a whole other thing later. Maybe you're running dedicated servers on some Linux host somewhere else. Okay, so that's some notes over there. Right now, I have no plans for anything to do there. So in the authority update over here, which now we don't have to spam our debug log, this is where we're going to do things like listen for keyboard commands for movement. Now, again, we're going to be implementing some sort of turn-based system that we'd normally have in this game. So you'd have some sort of like, you have a limit to how much you can move in one turn, usually in these things. So something like, so you have some sort of max movement per round? Movement per turn is some distance. I don't know what the distances are on our map. It's 5. Try that. And then we'll have something like movement left. And we're going to want some sort of function that is something like new turn. This is the start of a new turn, so we need to reset our values. And we're going to have to figure out some sort of synchronization for this with the server and things, again, to validate that things aren't cheating. Let's hold up on that. We may not use the movement left right away, but the idea is to like reset it to something like this in some way. Runs on server? Sync vars? Question mark? I guess same thing here. Sync vars? We don't know. Game manager, movement per turn. Yeah, but maybe it does vary per tank. Maybe your tank has a movement buff for some reason. And yeah, we might want to resync that. So something like, you know, void new round. So that's different from new turn. So in new round, we reset our movement per turn based on the game manager's default value, etc., etc. And remember, locally you could hack your number here to be like 9001. But the server will still know what your actual movement per turn is supposed to be. And then the question is, how are we making sure that when the movement happens, the right thing happens? But we'll see. So we're going to listen for keyboard commands for movement. So we're going to do something like, I don't know, we'll assume we're going to use the axes, like the horizontal axis for movement, which by default is bound to your arrow keys and A and D, and also if you're using a joystick. Sure. So float movement is equal to input.getAxis horizontal. There's a million different ways you might want to handle the movement. Maybe you want to do mouse clicks, in which case, you know, you click the mouse somewhere and then it figures out, okay, how much movement is that, and then it feeds it in. But in the end result will be, we are trying to move 5 pixels to the right, or whatever it is. Whether we get that from a keyboard input or a mouse click, or the AI is deciding what it wants to do, we'll see how Jesus, that's loud. I normally have my volume set quite a bit lower because the games are usually, I want to make sure it's not echoing too much, but there's no background sound. Super Steve! Thank you very much, Super. New here. I like whiskey. I like chocolate. Someone just notified me about your Quill 18 Creates YouTube page. This is for all the free content you'll be getting in the near future. Thank you. Hi, chat. Thank you very much, Super Steve. I hope you enjoy it. I do really like my Quill 18 Creates YouTube page. It's so much work to make programming content, but it's so satisfying. And nothing makes me happier than when I get a message from someone that says, hey, they've gotten into game design now, and they're making games, and they're working on stuff, and, you know, they got some of that from watching the videos. It's very, very awesome. So thank you very much. Thank you very much, Steve. And for everyone who watches. You are bringing me back to when I was programming an Unreal script for Unreal Tournament. Nice. Yeah, I've never done much work in the Unreal Engine at all. I know it's quite good, but, you know, so is Unity. We should use polar coordinates. Zervin, you're breaking me. Okay, so we have some sort of movement. And then what we're going to do is we're going to want to move ourselves. So we have authority, and we don't want any input lag. So let's move ourselves. So I don't know what that's going to look like long term when we've got like complicated terrain and we got to worry about like what does it mean to like, can you move up slopes? Is there a limit to the angle? You know, all these different features. I don't know what that will be because I don't know what our landscape will be. I don't know how much like friction and traction and all these things. We don't know those answers yet. Right now, we're just going to move. We've got a flat plane is what we're working on. So we'll just move directly. So let's do a transform dot translate. And we will just move ourselves. So the movement here is in the x-axis. I suppose we need some sort of speed variable. And what this is the like sort of units per second that we move. Just because the input here will always be like from -1 to +1. So we actually want to multiply the movement based on our speed. And that's not, like, you could set it to, like, 1 billion. It's not cheating. That just means, like, the very first second you tap your keyboard, you're going to go your full movement and then stop, and then you'll be done with that. And then, yeah, we probably want to do some sort of, like, clamps. We could do it here, I suppose. mathf.clamp. So we want to make sure that the speed... Oh, then there's a positive and minimum thing. Like, here, I'll put in a to-do. To-do. Track movement left. Okay, we'll come back to that. So what we're doing is our movement is just going to be our X motion. Our Y motion is probably going to need something because of slopes and stuff. That'll come in later. It's actually not that bad to work out. Because what we can just do is check the height of the pixel that we're standing on. Check the height of like the pixels that we're next to. If it's greater than whatever, then that's too sharp of a cliff for us to go up. If it's still above us, we might want to make us actually move a little bit less because there's some sort of difficulty. Maybe we want that, maybe we don't. You know, arcadiness versus realism, these are all kinds of different things that we're going to want to balance later on. So we're going to move ourselves. So now, if I have done this vaguely correctly, we should be able to move now. It's not going to be synced to the network. Give them the clamps. Whoop, okay. I think the ×5 is a little much. Let's just... I'm actually wondering if like point... Oh! I am an idiot. Times time, not delta time. Because otherwise you get frame rate dependent speed and most of the things go way too fast. And honestly, like the movement speed is probably something you could just configure as an option for yourself. Maybe you want your thing to move like really, really fast and instantly. Because it's not going to change the limit amount of movement that you've got. So we got that. What we probably want to do is have the sprite modify itself depending on the direction that we're moving in. You know, just have it mirror itself because... whatever, doesn't matter. I mean, you could have it so that, oh, it costs you a bunch of movement to turn around, or it's a tank. You don't have to turn around. You could just keep going like this. Maybe you have a symmetrical tank design like the one with the dome. But, then, you know, those are all visual things that we don't care about. Okay, none of this movement is being synchronized over the network. We are moving our own local object, but we're not telling anyone on the network what the heck is going on. Now, if we threw a network transform component on this, it would automatically, what its job is it listens to our position and says, is this different than we were last frame? It is? Okay, we better send a network update and letting people know that we have changed over here. But we might want more fine-grained control. Maybe for now I'll just set that up, but it's easy to imagine a situation where what we want to do is we want to personally, do we manually tell the network where we moved and how often? Because here's the interesting things in these games, right? In a sense, the only thing you need to do is tell the network where you ended up. You don't actually have to tell the network every little move that you do. You might even want to enable some sort of undo command. Like maybe you start moving and you realize like, oh, I moved too far, I fell off a cliff. Tell you what, let me just rewind to where I was and then try that again. Is that a feature you want or don't want? It's a little bit more hilarious and arcadey if you don't let people rewind that, but it can be more strategic if you let people sort of undo their move. And maybe like the movement limit is just like movement from where you started or something like that. So you could do that and just like, okay, when you lock in your movement, that's when we're going to send the message to the network of here's where I moved to. And then again, the server might want to do some checking when you send your movement information, whether it's your final move or not, or all your queued up movements. That's the other thing. We could just store up all the movement queues and then send them sort of one big batch. The server will want to check, hey, are all these moves actually legal? And if it's not, send the correct position or just refuse to pass it on. Because the way we tell the network where we moved is we would send some sort of command, right? Update position. Because remember, sync vars only go from the server to the client. The only way for a client to send a message to the rest of the network is to send a command to the server. So what we can do is send a message to the server with my new position. And then, so on the server, we have a command update position with a vector 3. New position, like that. So we can send this constantly or not. Let's say we were going to send this constantly, just for cuz, okay? So we got this new position that gets sent in. And what we're going to want to do is we're going to want to have a sync var that is a vector 3, which is going to be something like the server position. This is the position the server considers this tank to be in, and is the one true position of the tank from the network point of view. So we've got some sort of server position over here, and it's a sync var. And so the server, when it gets this new position, to do check to make sure this move is totally legal, both in terms of landscape and movement remaining, or some damn thing like that. And then what it's going to do, it's going to set server position to be equal to the new position, assuming this is fine. Now all of a sudden we've got an interesting kind of mechanic where each client has an option now. Okay, so we do some sort of generic server update in our update here, which, burning damage. Then in the has authority, we do stuff on, because this is the object that we own, and basically we take in feedback. And then over here, we do something like, are we in the correct position? What we want to do at this point is make sure that we agree our position on our screen matches the server. Now, in a sense, we could do something like if has authority is equal to false. Okay? We don't directly own this object, so we had better move to the server's position. Right? So what we want to do is we want to move towards the server's position. And we want to do it smoothly. We don't want to teleport, because we're going to get, an update every few milliseconds with the updated position, and we don't want to blink from one to another. As long as the updates are coming in frequently enough and the movement's not too fast, then maybe, teleporting from one location to another will look fairly smooth. But it might not. So what might be best is, instead of teleporting instantly to the new position, how about we smoothly move to the new position as we get more and more updates? So there's a couple of different ways. You can do lerps and things like that. I think we want to do the smooth damp, though, which is like the greatest. So vector 3, there's a bunch of smooth damps. There's mathf.smooth for a linear value or an angle, but there's also a vector 3 version of smooth damp. So this will do a smooth and dampened movement, sort of spring-like movement, from the current position towards the target, and get it to be like non-jerky as much as possible. And it tends to work really nicely. Just throw smooth damps in everywhere, and everything just looks just a lot nicer. So what this wants is, this wants our current position. or the current vector 3 that we're moving from, in which case it's position. So this is the position that this local client has for this object. This is where the tank is visible on my screen. This is your tank. This belongs to you, but I'm playing the same game. And so on my screen, your tank is currently here. But the server position is somewhere else. So I want to smoothly move where I see your tank from where it is now to where the server tells me it should be. Then we need this funky reference value for current velocity. I'm going to go and leave that blank for a second. And then it wants a smooth time. This is how long it takes to go from position A to position B, generally speaking. I don't know, quarter second? Now keep in mind, while we're doing this move, the server position might keep changing, but that's okay. We'll keep sort of chasing that server position in kind of a smooth way. And at most, about a quarter second will pass. Because of the nature of this game, we don't need instantaneous snappy movement of the tanks from one to the other. Depending on your game, like if it's a real-timey first-person shooter kind of thing, where you need to know the position to be as accurate as possible, as instantly as possible, you might want to do this differently, but you also might want to do some sort of like trailing hitbox thing. Hitbox and movement position and networking is very complex for first-person games like this, because there's always, let's say there's 100 milliseconds latency between me and the server, and another 100 milliseconds latency between you and the server. Me, the server, and you all have a completely different opinion as to where I am personally positioned at this particular time. So how do you work those details out using a variety of predictive and interpolating values and all kinds of different stuff? That's not going to be a problem for us because this is a turn-based game. So it doesn't matter sort of what kind of delay we have in the motion as long as it doesn't feel too laggy, because when it's your turn to shoot, no one else is moving at that time. I mean, we don't have that implemented yet, but that's the idea. Oh, right now we're making sort of a real-time shooter pew-pew kind of thing, which is interesting. And it might be a viable game, to be honest. And so there might occasionally be some differences of opinion between two different clients in the server as to where someone is positioned, which is a little less problematic if we're using like AoE explosives on everything, because there's always going to be that sort of inherent fuzziness about whether you got hit, so it'll mostly feel fairly accurate. Anyway, we need a value here, which is this velocity, and it has to be passed as a reference. So by default in C#, any objects that you sort of create, when you pass that object to a function, what you're doing is really passing a pointer to that object. You're saying, hey, there's this object somewhere in RAM. I don't have my camera up, so I don't know if I'm pointing to anywhere on screen. There's this object somewhere on RAM, and I'm passing you the address of that object. And so this function down here is running, but it just has the address of that object, so they're both pointing to the same place, and that's good. Technically, they each have their own individual copy of the object's address, but they're both pointing to the same place, so it's okay. With values, which include things like integers, maybe, I guess strings, or strings might just be immutable references in C#, I'm not sure. So integers, floats, and vectors. Vectors are values. So instead what it does is it copies the actual value, the actual number. So it passes the value of 0.25. If the function makes a change to the variable that is holding 0.25, that won't affect the main code over here, because it's just a copy of the value. So with the velocity, we actually want to pass it as a reference so that the function can make a change that then affects this value over here. We don't have to worry about what's going on with here. So we do something like server position smooth velocity. I don't know, whatever. Doesn't matter. It's going to be handled internally, but we have to pass it as a reference. It's a little bit wonky to have to like throw in that extra like syntactical sugar here, but it makes sure that it works. Let's just do this because that was getting quite long for my screen thing. So this will return a value that is moving from our current position towards the server. So every tick we're going to go ahead and do that. Are there three basic types of realization to this? Peer-to-peer, where all clients come to a majority consensus. Server-side, where server decides where the hit happened. Client-side, client decides where the hit. All of them have pros and cons, but there's ways to come to sort of a middle ground with that, where you're using a lot of predictive stuff, so that not only do you know the position of another player, but you know its velocity, and so each client is trying to do their best to position the other player where they think the player is in real time, as opposed to the most recent position updated by the server. And yeah, there's sliding hitbox stuff, and there's the idea that the server tries to keep track of where the actual player is and where this other client that just fired thinks the player is and what that means. So yeah, it's Valve has gotten quite a few PDFs they've released from like talks and presentations in terms of things that they've used for some of their games and stuff. It's a very complex topic with a right answer that varies highly depending on what game you're making and how its inherent mechanic works. So it's really nice if you've got games with like highly predictable movement. Like if you've got like a spaceship game that mostly runs with like say real Newtonian movement, then it's really easy to predict where the object is likely to be, and you can minimize a lot of those issues where it looks like you shot someone but it went right through them and didn't actually shoot, or it looks like you were behind cover, but you somehow took damage from something. Slightly off, but yeah. Okay, so this means all the clients will nice and smoothly do this. The interesting thing is, we could ignore this has authority equals false flag over here. The neat thing is, even on the server, this is running on the server itself is not instantly updating the unit's position, because the server might be a client, which is kind of funky and weird. Which means that if the server is running some sort of like hit logic, it's actually going to want to double check this server position as opposed to new position, or as opposed to its actual transform, because again, the actual transform is like the visual spot of this object, which may or may not be smooth. Now, we could like dramatically reduce the smoothing time. But the thing is, what if the player has made some sort of illegal move for some reason? I mean, we're not really, in a setup where that's likely to happen, but and we're not checking to see the legality. But if it's possible that there's some disagreement between what the client thinks he made a move and what the server says is possible, we're actually going to want the authoritative client to double check its server position over here. In fact, what will probably happen is we might want to do something like the client is going to wait a moment after like its move, and if a certain amount of time has gone by, or when the client, so let's say I'm moving, okay, we might want to hook on the server position sync var. We might want to hook on this. So when we receive a message from the server that the object position has changed, if I'm the authoritative client and the server position is like bad, but again, it might all be lagging behind. Like, we might want to have some sort of mechanic for like checking to see if the server's told us, hey, something wonky's happened. In fact, what we might want to do is have the server have an explicit command to send back that says, whoa, something went wrong. I need you to I want you to fix your position to this instantly right now. And we could do that. We could have a client RPC, which is something like fix position. So the idea is we've received a message from the server to immediately correct this tank's position. This is probably only going to happen if the client tried to move in some kind of illegal manner. So what we might do for something like that is something like, well, there's all kinds of different things. Ultimately, the server position is going to be getting updated automatically as part of the sync var. And if we're just a third-party client, we might want to just ignore this. But let's say, okay, you know what? Yeah, we're making the change right away. Transform.position is equal to new position. So if we're in the middle of a move and for some reason the server disagreed, we'll all of a sudden like instantly teleport back to like maybe the last legal position. So if an illegal move is spotted, do something like RPC fix position server position and return. That's a thing for another issue. There might not be a way that someone's going to end up in an illegal position. I mean, barring hack clients and stuff. So we'll see. So you're basically implementing something like tick rate now. Tick rate is automatically implemented by the high-level networking. It's set at a minimum delay of like 10 milliseconds. So it'll pool inputs for up to 10 milliseconds and send it. So the default setting has a tick rate of 100 hertz, which is pretty good, actually. Okay, so all this, there's a lot of extra writing, although 75% of this file is comments, just to do the movement. But I think our movement is now synchronized. And we've got, and half the code in here is like placeholder for when we want to get more sophisticated. Let's just confirm that our, yeah, we can still move our local tank. That's great. Let's do a little build. If says how many players can server tolerate. Maybe. I mean, we'll try to get something out that's interactable. It'll be nice to wait until shooting. So I'm going to have this side here be the host, just because whatever. So this is a host and a local client. I'm going to move over here, which has affected the server position, which should get synced automatically when we connect up. So I'm going to connect. There you go. And if I try to move, this is me moving. And can I get them both visible? Yeah, just barely. There you go. So you can see that sort of smooth movement over there. I mean, first of all, there's always going to be a slight delay to the start of movement because even on this local system, there's that 10 milliseconds where it like stores up the messages so that it can try to send them more efficiently and use less bandwidth overall. On an actual internet connection, it would be a little lower. And the way our SmoothNet works, it's going to move just a scooch slower because if we had our keyboard input like go from, to maximum speed right away, the SmoothNet is probably going to like not accelerate quite as quickly and just move more smoothly. But that's okay. For this game, it's perfectly fine. Again, things are a little bit different. If we're actually going to do a real-time combat game, then we might want to, do something so that players don't end up feeling, I guess I can go over the edge, don't end up feeling like, hey, that didn't look like it hit me. But I think we're pretty good right now. Whee! And over here, we can move the other guy to there, and we can check our client, and yep, they're all good and happy. And again, the time left gets synchronized as well. Again, but in terms of multiplayer, synchronized is a fuzzy value, because it's like learning about relativity and shit in physics. It's like, what? No, what? This hurts my brain. Okay, that's good. Let's get him to shoot. And we see the countdown being different in client and server. Exactly. Because there'll be that slight delay. Even more so if it was actually networked. It becomes like crazy because it's like the idea of what is simultaneous is completely out of whack. Completely out of whack. All right, so let's do some shooting. So what we need is we need a bullet, which means I need to find my Unity again. Okay, so we're going to create a prefab for bullet. Some type of bullet. Bullet dash normal, because we'll have different types of things later on. We need some sort of graphic. Again, I'm going to put the sprite inside of that. Now we're going to use one of Keeney things. Oh, that looks like tank shell. Oh, I like the missile. Here, we'll use that. There you go. This is some sort of bullet for us. Awesome. The other thing we're going to do for our tanks is we are going to go and add in some sort of hitbox for it. So again, let me put it into the world so we can take a look at it. With the hitbox, I like to have the hitbox be not on the main object because usually the hitboxes are really going to have to match the graphics. So it sort of makes sense to have it be as a sub thing, sometimes attached to the graphics. But in this case, what I'm going to do is I'm going to create an empty inside of this, and this is going to be just called hitbox. And hitbox shape is a whole other area of like discussion as to what the correct way to handle hitboxes and things like that are. But I'm going to use a box collider 2D here, and we're going to go and just resize this to be vaguely compatible with the size of the tank. Again, especially since we're going to be using a lot of like collisions and stuff, like, or sorry, not collisions, explosions and stuff. Um, a little bit of fuzziness is going to be okay. Whether or not these corners should be okay, maybe we should do polygon colliders, all kinds of things. You know, valid discussion, but I think for the point of this game, this is going to be a perfectly fine hitbox. Keep in mind, we are not going to be using this hitbox for actual physics movement on the ground or anything like that. We'll have to be doing something custom because we want something a little funky. Now, I'm going to go ahead and add a rigid body 2D to this, but I want it to be kinematic. Which, is this what simulated is in here? If not, it's effectively hidden. Wait, when you're using the 2Ds... it might just be the simulated thing. Unity, rigid, body, 2D, kinematic. What is it called these days? They kept changing it. Oh, is it just this? Oh, there it is. Pull down menu. Thank you. You're a kinematic body mice. What's your options? Static. The reason it's so different from the 3D collision system is because it's literally a completely different code base. I think this is based on the sort of open source, is it Box 2D or whatever system? So the way the flags work is a little bit different. There you go. You're kinematic. Excellent. So you are simulated, but there. So you're not affected by gravity or anything like that. And we can go ahead and apply the changes to the prefab, and I guess we'll make a prefab out of the bullet. If I hit play, I mean, nothing's going to happen. This thing's not going to start falling or doing anything weird like that. It does disappear because it's a network object, but that's okay. All right, good, excellent, wonderful. So now you have a hitbox just so that we can check. We'll probably use that to see if bullets hit things, basically, is the idea. So the same thing's going to happen with the bullet over here. I'm going to add a rigid body 2D, which could be dynamic. Some of them might be dynamic for a variety of different ways. Let's leave it there for now. That's going to be okay. And we're going to add a box collider 2D, which will automatically apply itself to the correct bounds for this object. I think, not that it's really a big deal, but I think what I'm going to do is trim the height down just a scooch to be sort of just the capsule body itself instead of the wings. I don't think it makes much of a difference when we're talking about these tiny little sizes, but let's do that. So this bullet actually is a physics-enabled object in the 2D system. So it'll fall. And if it wasn't for the fact that this was a network ID and or had a network identity and automatically became disabled when we start the game, this bullet should actually hit that thing. So maybe we'll fire the bullets with actual like rigid body mechanics. Although, with that in mind, the first rule of networking is never, ever, ever sync physics objects. Good God, you're asking for so much trouble. And in fact, the same thing will be true here. What we could do... Well, actually, that might be okay. The question of how do you sync physics object always comes up. The physics system in Unity is not 100% deterministic for a variety of different reasons. Which means if you set up two physics-enabled rigid bodies on two different computers and start them off at the same time, they might do slightly different things. They might bounce in slightly different ways for a variety of different reasons. Doubly so if, for any reason, there might be a slight time difference between various objects that are moving in the scene. The two objects might not be in exactly the same place on two different computers, and weird and unexpected things will happen. One of the best ways to avoid that problem is, well, first of all, don't use physics, but let's assume you want to use the physics engine to, tumble something in a half-realistic manner. Only have the object be a true rigid body on the server, for example. And on every other end of things, have it just be like, say, a kinematic body that is updating its position in real time. That is perfectly fine. Now, in this case with the bullets a lot of times aren't really going to collide with everything in a normal sense, and they don't necessarily need to be 100% deterministic. If there's a little bit of fuzziness, it's not the end of the world. What we could do is spawn all the bullets with a certain initial velocity, set up with network transform, set the network transform update rate to 0, which is the example that they use. So when the object spawns, it synchronizes its position and its velocity and all those things, but it never bothers updating it because they both move the same way on both ends. But still, if there's any sort of collision with a tank, the clients will basically kind of ignore it. It's just the server determines if there's a hit or not and causes the bullet to explode at a certain time. It can lead to the situation where a bullet looks like it's in a slightly different position on the client from the server. But I don't think that's going to happen much. You know, we're not going to see much more than like a 1 pixel deviation. If you do end up with a bullet that does it's like a weird bouncy bullet that goes all over, so there's going to be sort of a lot of collisions and recalculation, then those errors might build up over time, and then the bullets may not match up, in which case you might want to do just more and more synchronization of things. Maybe every time a bullet like collides with something and is going to do a bounce, have the server send an update to its position and things like that at that point, so that the client tries to keep its copy of the bullet as synchronized to the server as possible. But ultimately, the server is responsible for, in this game, responsible for determining where the shots are going and what they're supposed to do. So, server-side calculation to make it cheat safe. And that's the thing. The server is the only version of the bullet that's going to be real. The server is the only one that determines if a hit happens. The only question is, how do we make sure that the bullet looks like it's in the right place on the client? And I think offloading most of the work to the client is going to be fine. And there's not going to be a way to cheat it. The client can't say, "Well, I wasn't standing here," and the client can't say, "Well, this bullet actually went this way," because the server is the only one who's going to be doing that kind of work. So we're going to have a bullet. This is going to be in some way networked. Or is it? Because here's the thing. The bullet may not need to be networked. All you have to do ultimately is the server has to send a signal to the clients that say, hey, make a bullet appear here with a certain speed. Every client could then go and spawn its own copy of the game object there. Instead of using network server.spawn, for example, we could have every client. So the server can instantiate its bullet and then just send an RPC to the clients and say, by the way, could you instantiate a game object at this position with this velocity? And every client will just make their own copy there and have a completely non-networked bullet. That being said, that might be a little bit more work for bookkeeping. We're basically duplicating some of the work that Unity as network system does for us. And if we do want to occasionally resync the bullet's position, it's just handier if we've got a network ID. So I'm going to suggest we do put a network ID, or network identity, on our bullet. It's not going to have any kind of local player authority. The only person who has any authority over the bullet is going to be the server. Although, again, each client side is going to try to do its best to move the bullet in the correct manner, but no client is going to be able to send a message to the server with commands for the bullet. That's the side of it. It's very weird. Again, on a client, you can take a game object and do whatever you want with it. You can make it 1,000 times bigger and move it somewhere else, but it's not going to do anything to the server or the other clients. And that'll be the case here. All right, so the bullet has a network identity. That's good. Probably it's going to have some sort of script on it. Bullet. Done. Like that. And again, most of the work of the bullet script is going to happen on the server. So we'll be checking for something like that. And we are going to synchronize its position with a network transform. Because it's going to be okay. Network transform does have some issues, but in this case, it's going to be okay. So it's got a few different ways that it can sync. It can just sync the transform, so that would be just the transform.position and rotation, and I think scale. It can also sync some of the rigid body stuff. This stuff, there's all kinds of issues, okay? The rigid body syncing is funky and weird. Your mileage may vary. In particular, when I was testing the rigid body thing earlier, in another game that I was doing, the network send rate, it would update the position of the rigid body, and I think it would update the velocity of the rigid body, but it wouldn't update the angular velocity. Like, it didn't send everything for some reason. Even though I had, the sync angular velocity thing checked on, or I don't know. There was something weird. In any case, here's what we're going to do. We're going to sync the rigid body. We are not going to automatically send any updates. So this is the number of network updates per second. You can set this to 0. So what it will do, it will sync the initial position, rotation, and velocity of the rigid body, and then it will never send another network update again. So each client will be responsible for moving the bullet around. Again, only the server gets to decide when something is going to get hit, but the clients will still like move the bullet around because this is going to be a normal physics object, and there we go. So there's a bunch of flags we can set up too. I think we can leave them as is. I think snap threshold is if for some reason our position gets too far out of whack, it'll just insta teleport there instead of doing smooth things. And I don't think any of this will matter because we're doing a 0 network send rate on this. So we'll go ahead and apply that. And then we'll remove the copy of it from the game. And this tank with the hitbox, we're going to make sure that that's been applied to the prefab, and we'll remove you as well. So let's get some shooting going on. And that'll probably be the end of today's run. Okay, so our tank and our bullet script. So with our tank, under has authority, and this is where we're listening to updates and stuff like that. One of the things we might want to check is, like, did we shoot? Again, how are you supposed to control the shooting stuff? You know, if it's turn-based or whatever, that's what I'm talking about. Like, how does the shooting work? Ultimately, we're gonna have some sort of do shoot, and it's probably gonna be a command. Thank you to all the January Patreon supporters and these Mic Check supporters. Yukofin, Lurking Ninja, Dubiouser Curl, Tiburon, Mighty Mix, Pavel Zdanov, Adam Keenan, Michael McClintock, Aaron Doibson, Rorskal, Gurko Dries, Jesper Bisgard, Julien Gelafon, Soren Tried Anderson, Marisfield Vold, Speedy Savant, Steven Stager, Thomas Oberson, Jason Yanity, Easter Egg Productions, Neil Blakey, Milner, and everyone who watched, shared, favorited, and subscribed. Thank you so very much.